Hello, ladies and gentlemen. Happy Wednesday. I hope you are having a good day. It was a pretty nasty storm last night, but it has stopped, and we are ready to go. Okay. We're going to be working on lesson 932 today, 932 day 2 tomorrow, and then a quiz on Friday. So yeah, let's get to it. You are going to need graph paper and a pencil today. So please, again, please make sure you're doing these problems. I know it can be very easy to just sit and watch and just take that passive role. But if you are doing that, you are not experiencing and not practicing and not checking the problems. And it's one thing to just watch someone else do it and be like, yeah, I get it, no problem. It's another thing to actually do it yourself. Okay, so I am going to ask you to please do the problems and make sure that you are then unpausing and checking your work. Okay, let's get started. What if the inequality is not linear? We've been working on graphing inequalities linear, but now we're looking at nonlinear. In lesson 931, you discovered that the solution of a linear inequality with two variables can be represented by a shaded region on one side of the line. But how can the graph of an inequality help you solve the problem? And what happens when the inequality is not linear? Okay, so let's get started with that. Okay, here it is. First problem. Review what you learned about graphing inequalities in lesson 931 by graphing the inequality below on graph paper. Please write out that inequality on your paper. Please then make a coordinate grid. I want you to graph it, do the entire process, see what you end up with. Got it? When you're done, unpause it and we'll compare. Okay, hopefully you are finished. Let's compare. So the y-intercept is -3, so that would go right there. And then slope, rise over run, -5 over 3. So I would go down 5, 1, 2, 3, 4, 5, and over 3. That would give me a point right there. And then 1, 2, 3, point right there. And then 1, 2, 3, 1, 2, 3, 4, 5, point right there. All right, there are my points. Now, the next point I need to decide is if it should be a dashed line or a solid line. Okay, so if you look at the inequality, it does have an equal sign, meaning all the points on the line do work. Therefore, I need to connect these points. And don't forget the arrows at the end, and that would be your inequality. Now we do need to do one more thing, but before I get to that, let's answer a couple questions here, okay? What is a minimum number of points you need to test in order to know which side of the line the solution falls on? 1. You really only need 1. Just be careful that when you do that 1 point, you do it correctly, because if you don't, then the whole thing is off and there's nothing that much that can be done. So try to be sure that you do that 1 point right. Cool. Orville thinks that using 0.00 to test the inequality is a great idea. Why is using the point so convenient? Well, it's convenient because it basically eliminates this part right here to where all you have is 0 is greater than or equal to -3. And since it is, 0.00 is there, so everything on this side gets shaded in, and that is the answer. So using 0.00 eliminates one of the variables with the slope, and it just gives you basically comparing 0 to the y-intercept, which makes it a lot easier. Okay. Orville thinks that using Anita decided to use a point -3, 2, -3, 2 to test her inequality. Test the inequality with her point. Does this point help you decide which side to shade? Why or why not? So if I go here and I'm going to use the point -3, 2. Okay, -3, 2. So I put the 2 over here. 2 is greater than or equal to -5 over 3 times 3 minus 3. Okay, -3, 2. Oh, I forgot the negative. My bad. Okay, -3, 2. All right, then I get 2 is greater than or equal to this right here. When you multiply this, I get 15 divided by 3, which is 5 minus 3. And then 2 is greater than or equal to 2. Well, it's equal to, but it's not greater, it's just equal to. And if I actually go to the equation, I go -3, 2, it's that point right there. The point is actually on the line. So does it really help you find what side gets shaded? No. The point that you pick to use for determining shading has to be off the line onto one of the two sides. Again, 0.00 is by far the easiest point to use. Cool. That was just a review of what we learned yesterday. Hopefully you guys all felt comfortable doing it. Kind of one of these shut up, Mr. Ramirez. Now, I hope you're not fast forwarding and skipping me, but hopefully you guys feel comfortable doing it. If not, we got some practice problems. Here we go. Now, this one usually stumps students. I'll be honest with you. Most students have a hard time with this one. And so I want you to go ahead and try that. Please go ahead and write that inequality and show me. Show me on a 4-quadrant graph what the answer would be. Cool. When you're done, unpause it. All right, let's see. X is less than 2. Well, you're like, oh, well, it's going to be a number line, and I just put an empty circle here, and woo! No, that is actually not true. That is on a number line, but right now we're doing a coordinate grid, a 4-quadrant grid, and therefore we need to make it everything less than 2. So we actually have a horizontal or a vertical line here on 2. Would it be dashed or solid? It would be solid. Oh, I'm sorry. It would be dashed because it does not include 2. So a dashed line all the way down with arrows. And then 0.00 is 0 less than 2. It is. So all of this side would get shaded in. That is how this would look on a 4-coordinate grid. Now, if I didn't have that, if I just said, show me somehow or another that, yeah, most of us would go to just a number line and say 2, 1, 3. Hey, it's empty there, and then everything shaded over there. That's fine, but on a coordinate grid, it would have to look like that. Did I get you? Did you get it right? Okay, good. One more. This one's fun. So now I really do. Absolute value. And so we've talked about it a little bit. Please go ahead and write this equation down and graph it and see what you get. Okay? All right, now, go for it. The interesting thing with this one is that basically there aren't really any shortcuts. You really kind of have to make a table. Okay? Oh, X and Y. And then, I like to go -3, -2, 1, 0, 1, 2, 3. You really kind of have to make a table for this. So 2 times -3 would be -6 minus 5, or -1 would be -5. Absolute value of that would be 5. Sorry, I had to check there. And then the second one, if X is 2, 2 times -2 would be -4. 4 minus 1 would, I'm sorry. 4. So 2 times -2 would be -4, minus 1 would be -5. So I actually did the first one wrong, didn't I? Okay. 2 times -3 would be -6, minus 1 would be -7, and then the absolute value would be 7. Whew, okay, my bad there. This would be 5, and then hopefully you start seeing the pattern here, okay? -2 times 1 would be -2, minus 1 would be 3, 0 would be 1 because we find the absolute value of it. Now 2 times 1 would be 2, minus 1 would be 1. Absolute value of 1 would be 1, okay? 2 times 2 would be 4, minus 1 would be 3, and 3 times 2 would be 6, minus 1 would be 5. So it looks like that. And you're like, wait, what's going on here? Well, I do know that I have to have a vertex, and the vertex is going to be between these 2 points. It's kind of like a parabola. So 0 is 1 and 1 is 1. That means my vertex must be in the middle of it. And then 2 is 3, and -1 is 3, and 3 is 5, and -2 is 5. And it would look like this. Boom. Okay. And then I plug in 0.00. Okay. 0, is on the outside of this line here. So it would shade in this other part. If it does work, it would shade in everything around it. If it doesn't work, it would shade the inside of the V, which is interesting. Okay. So 0 is 0 less than the absolute value of 2 times 0 minus 1. 0 is less than 2 times 0 is 0, minus 1 would be the absolute value of -1, which is 1. Is 0 less than 1? Yes, it is. Therefore, everything on the outside of the absolute value would get shaded in. Cool. All right, ladies and gentlemen, that is it for today. Just some practice with some problems. Your homework is going to be problems 84, 85, and 88 on the homework. Tomorrow we will continue practicing some of these problems. It'll get a little bit more complicated, but hopefully it makes sense and you're doing well. So let me know if you got any specific questions. Otherwise, have a good day.